In this lesson, we are going to look at the second derivative test, which will allow us to determine whether critical numbers are points of inflection and find local max and min without actually doing that interval table that we've been doing. So if you remember, y prime, the first derivative is the slope of the tangent at any point, and then the second derivative describes the rate of change of y prime, or the rate of change of that slope. So for example, if I approach a turning point here where we have a maximum value, so here my slope of my tangent is 0, right? It has a horizontal line, so the slope is 0. If I pick a point, let's use a different color here. So if I pick a point here and draw the slope of the tangent, I have a positive slope. If I pick a point here, continues to be positive. Pick a point here, continues to be positive. Once I pass that turning point, if I pick a point here, now my slope is negative. If I pick a point here, my slope is negative, and so on. So I can see that if the function is increasing, it's positive slope. If it's decreasing, it's negative slope. And the rate of change, as we discussed in the previous lesson, is able to tell us the concavity and whether it's concave up or concave down. Previous question, we had a change in slope value from a positive slope to a negative slope. And then likewise, if I have a minimum point, so here we have a turning point which is a minimum value. So y prime is 0. So on this side of the graph, we have a negative slope, continues to be negative. Once I pass that minimum value, then the slope is now positive, and it's getting steeper as I go to the right. So again, I have a change in value from negative to positive here, and then in the... So how is it going to help us find these local max and min? So previously we found our first derivative, and then we used the interval table to determine whether it was a max or min. We were looking for that change in sign going from positive to negative. So if f prime of c is 0, if the second derivative, so f double prime of c is positive, then the function is going to have a local minimum, and if it's negative, it's going to have a local maximum. So previously we found our critical numbers first by finding the derivative. We set it equal to 0, and then we factored to find those critical numbers. So I would get x minus 3, x plus 1. So that tells me I have critical numbers at x equals 3 and x equals negative 1. And then we were making a table of values to determine whether those numbers were maximum or minimum. We were looking at a change in sign. So just put our factors down the side here. And we were looking at the first derivative, the sign of the first derivative. So obviously 3 stays positive in all intervals. I'll pick a number less than negative 1. So we have an increasing function. I'll pick a number between 1 and 3. I'll pick 0. We have a decreasing value, and then we picked a number bigger than 3. And then we looked at whether we had a change in sign. So we have a change in sign here, which told me there was a local max, and then we had a change in sign here that told me it was a local min. So that was one way to find our maximum minimum values with our interval table. Another way to do it is with our second derivative. So we can do a second derivative test. So the first thing we do is find the second derivative. So the first derivative was 3x squared minus 6x minus 9, and so the second derivative is 6x minus 6. And what we want to do is we want to take those critical points and substitute them into the second derivative. It's a quick way to tell whether they are local max or local min. So the first critical point was 3. So I'm just going to put 3 into this second derivative and see the result. The result is positive. So that tells me, and think of positive as a smiley face. You have a positive attitude. That tells me that it is a local minimum. So if you have a positive result, it is a local min. If I put in the second number, -1, I get a negative result. So let's think of negative as a frowny face, and that tells me it is a local max. And then when we look at our table, that was confirmed in the table. We had a local max at x equals -1, which we confirm with the second derivative test, and then we had a local min at 3, which we confirm with the second derivative test. Earlier, perhaps not on this previous slide. Yes, so right here we do have an exception. If we do the second derivative test and we get 0 or does not exist, then the second derivative test fails and we go back to using the first derivative. But for the most part, so let's look at another one. Find the local max and min values of this. So we'll find the first derivative. And then we'll find the second. Well, actually, let's find the critical numbers first. Doesn't really matter the order, but let's do our critical numbers. So I'm going to factor out -4. So I have a critical number at 3. And I want to know if that's a max or a min. So now I'm going to find the second derivative. Second derivative is just a constant negative, so it doesn't matter what number I put in. It's always going to equal -4, which is negative, so frowny face. So that tells me it is a local max at x equals 3, and there is no local min. I put this in here. If we get, it's a quick way to determine whether you have a local max or a local min. Okay, we'll do one more here. So we'll do f prime of x. And then we'll do f double prime. And we'll take our first derivative and we'll set it equal to 0 to find those critical numbers. I see a common 3x. So we have critical numbers at x equals 0 and x equals 2/3. And once we find those numbers, we can substitute them into the second derivative to see whether we get a positive or negative result. So we'll put in 0. Oops. So 6 minus 0 is 6. That is a positive smiley face. So that is a local min. And then we'll put in 2/3. Which works out to be -12, which is negative, so a frowny face, and that is a local max. So this eliminates, it's a little more efficient than doing the interval table. The interval table is fine, but this is just a quick test to see whether you have a local max or a min. So a local max at x equals 0, and we have a local min at x equals 2/3. Is, I don't know, a that up here. One thing to keep in mind, second derivative, if we do the second derivative test and the value is 0, then the second derivative test fails. I think I might have